folks, today we're going to talk about the two proportion z-test. Unlike the one proportion z-test where you're comparing the true proportion to an actual value, here you have two different proportions and you're trying to prove that one is greater than the other or less than or not equal to the other. So in all of these hypothesis tests, you are starting with the assumption that they are equal, and that's a really big idea. Okay, so if you are assuming that they are equal, then what you're really saying is that the difference between them is equal to 0. This is really important because the distribution that we'll be using is going to be assumed to be centered at 0. Really big idea. And so the statistic, right, we're going to have a p-hat from two different populations. They'll both have to be SRSs or assumed to be SRSs. They will both have to be less than 10% of the population of interest. And you'll have to check the normality for both samples. But the assumption is that the center is 0, and you're going to be finding a statistic now that's the difference between two p-hats. So let's say the p-hat sub 1 minus p-hat sub 2 is over here. You're going to hope that it's far enough away to be able to reject that the difference is about 0, right? So that difference has to be statistically significant. We're going to figure out the statistical significance by figuring out that probability, and we'll get the probability by using the z-score. So I just want to talk a little bit about how that z-score is constructed. Okay, the z-score, as always, is an estimate, which now is the estimate of the difference. Which is the p-hat sub 1 minus p-hat sub 2 minus the center of that normal curve, which is 0, divided by the standard error of the difference. And so where is that standard error going to come from? It's going to come from the difference of the two. So remember when we subtracted random variables or added random variables? We always added the variances. Okay, and so just so you know where the formula comes from that we'll be using here. Okay, remember we're looking at the difference between the two. That difference comes from the fact that each statistic, each p-hat, right, has a standard error. I'll leave the hats off for a second here. Oh, there's sub 2. And so if we were to figure out the standard deviation or the estimate thereof, we'd have to square these. Add them, and then take the square root. Okay? So the formula that we get for the standard error of the difference of the two statistics now is equal to, right, this squared would eliminate the radical, so it would be PQ over N, all for the first sample, and then PQ over N for the second. And so you're going to see that formula on your formula sheet. So I just want to touch base on that formula, give you an idea of where it comes from, okay? And so let's talk about a particular problem, okay? This is a very interesting problem. They actually made a movie about it many years ago called The Civil Action. And it's a local problem, so I thought you might find it interesting. It used to be in the textbook. I'm not sure if it's still in your textbook or not. But it is a story about East and West Woburn. Happened in the early 80s. And what was happening was a tannery, which is, they dye leather, they were dumping toxic chemicals into the river behind the tannery. And so that, of course, is going to cause some major problems because that river ran into a water source for the eastern side of Woburn. And so what they noticed was that over the course of time, there were many people who were diagnosed with cancer, and there were also many birth defects on that side of town. And so it was a true story. They made it into a movie. In this particular case, they wanted to see if there was a difference, a statistically significant difference between the rate of birth defects on the east versus the west side. Okay, so in the notes you'll see this problem. And I'm going to use the subscript of P hat sub E for the proportion of birth defects on the east side. They had 16 out of 414 births during this period of time that they did the analysis. And that's about 3.8%, 0.0386. Versus on the west side during the same time, they had fewer births, but they only had 3 birth defects noted at that time, and that was a difference, that was a percent or proportion 0.0132. And so when we do a 2 proportion z-test, we're trying to see if these are significantly different, or if this difference could occur by chance, right? And so that's what that p-value is. Under the assumption that they're the same rate of defects, how likely is it that we notice a difference in this case, right? The difference between the two is, we subtract those, 0.0254, okay? And so we can do a hypothesis test that focuses on the fact that under the assumption that they're the same, right? So they're from the same population. If you pull these together, some people call that the pooled P or the combined P. Under that assumption, how likely is it that we observe a difference into about 2.5% in the birth defect rates? Being that East Woburn observed 2.5% more birth defects during that time than the west side. So we could do our hypothesis test, okay? And the hypothesis test would be carried out as follows. And again, my full notes are in the Schoology file online, right, for this week, all right? But just to kind of outline them for you, right? I would be assuming that they're the same, all right? And again, I'm going to use my parameter here, no hats in the null hypothesis. Assuming they're the same, right? This means that P sub E minus P sub W equals 0, okay? Don't have to write that, but this just gives you the idea as to why the center of that normal curve is 0. And we're trying to prove that, in fact, no, it's greater on the east side, which is the side that had the water source that was polluted by the tannery. Okay. And so if you were to do the test out formally, right, the conditions will be as follows. The first would still be the SRS. You would assume that you had an SRS from each population. Well, in this case, it's not really an SRS. It's during that period of time, but we're going to have to be willing to treat. You would have to assume that you have less than 10% or max 10% of all the births that ever to occur in East and West Woburn, which certainly you do. But the normality condition is very different for a 2 proportion z-test. And I'd like to bring you back to the idea that all conditions for hypothesis tests are based on the assumption in the null hypothesis. So the assumption is that they're the same. So if they are the same, that means that they're from one population where the birth defect rate is the same. So we're going to pull these P's together, and what we do is, right, the pooled P allows you to add fractions, like people told you to never add fractions, add the numerators and add the denominators, if you look at my notes here, right? So if you had 16 out of 414, excuse me, on the east side, and if you had 3 out of 228 on the west side, right, you're pooling them together. So under the assumption that, they are the same, they're not statistically different, if you pull this together, you get 19 out of the 642, which is about 2.96%. And this pooled P is what you use in the normality condition. Okay, so the normality condition would say that you're going to take each sample, so n sub e times p sub c, that has to be at least 10, n sub east times q sub c is at least 10. You'd have to do that for all, or both of the populations, I should say. All right, so the conditions are kind of very labor intensive for the 2-prop z-test right here, because you have to do it for both populations on the pooled P. All right, just want to check and see if you can see my board here. Yep, good. And so at this point, I did check them. You can see my notes. There was one that was not greater than or equal to 10. It was the 228 times 0.0296, which is about 6.7. So I would say, proceed with caution, but I'm going to do this anyway. So at that point, if you were to perform the test, you would want to do what you always do, which is make a sketch and find the test statistic and the p-value. Right? So the assumption in the null is always the center, and the assumption in this case is that they're the same, so their difference is 0. And the difference between the two, we said, was about 2.5%. And so we're looking for the p-value there. It's a one-sided right-tailed test. And so to figure out that probability, we need to find a z-score. So the z-score is always the statistic, which in this case is the difference between the two proportions, minus the center, which is the 0, over the standard deviation of the statistic, which in this case is going to be based on the assumption in the null hypothesis. So we're going to use the combined p, right, PQ, over each population. And again, I just kind of set that up. At this point, I don't even really plug in the actual values. I just set up the idea that I do know what I'm talking about. I have the right standard error formula. I know you can put the actual number in if you want. But then I pick up my graphing calculator. And to do this on the graphing calculator, let me grab that. You're going to go to, of course, your stat tests. And you're going to go to the 2-proportion z-test. Okay, the 2-proportion z-test is going to give you basically 4 things to input, right? So I've got my p hat sub e, which is the 16 out of 414 in East Woburn, my p hat sub w, which is the 3 out of 228 in West Woburn, and it was a greater than test. When I hit calculate, right, I get a lot of information there. So let me just take you through what everything is. Okay, the first is the z-score, right? So the z-score is 1.882. So we got the z-score. And then the next one down is the p-value.
okay, which is 0.0341. You've got your two p hats, which is our p hat sub e and our p hat sub w. Sorry, folks, it's hard to look and read at the same time. And then the p hat here, the 0.0295, that's actually the combined p. All right, they're not able to do a p sub c with the pixels here on the screen. So that p hat is the combined p. Okay. So when I do this, I kind of do this first because it gives me the combined p. I don't have to, I mean, it's just arithmetic, but you know, it saves me from doing that as well. So I need to be able to read that. So I've got my z-score, which is the test statistic, 1.82. The p-value, which is 0.0341, okay? And that p sub c, which I would need that number to be able to put that into my conditions that we already did, right? And so you would then, of course, at this point, do what you always do with hypothesis testing and make the conclusion. You would say that since the p-value 0.0341 is less than alpha level of 0.05, we reject the null hypothesis that the proportions are the same. And therefore, we have sufficient evidence to say that the proportion of birth defects in East Woburn is greater than the proportion of birth defects in West Woburn. So perhaps they could use that at trial, which they did ultimately get, I believe, about $8 million for the families back in the 80s. But often hypothesis testing and confidence intervals are used in trials. Okay. So two proportion z-test, very similar to the one proportion, just a little bit more work in the conditions. The formula is a little bit larger. And sometimes you can approach this with confidence intervals as well. So I'd just like to use a few moments to talk about confidence intervals for the difference of two proportions. All right, this is also in the notes that I have scanned on Schoology. Okay, and we could even do this problem using proportions. Using the confidence intervals. So the difference in proportions, in this case, p hat sub 1 minus p hat sub 2, and so instead of just a singular p hat, right, same setup, plus or minus z star times the standard error of the statistic, which, like I showed earlier, is developed by squaring the individual standard deviations to get the variances and then adding the variances, taking the square root. So in this case, if we have p1 sub 1 and sub 2, all right, we don't have a combined p here because this is not a hypothesis test. We're just constructing a confidence interval. Would have p sub 1 q sub 1 over n sub 1 plus p sub 2 q sub 2 over n sub 2. And so yes, it does look kind of huge here, but it can be built using the formula sheets they give you. But most important part is being able to interpret it, of course, okay? If we just take the example we just had, right, looking at East versus West Woburn, okay, if we were to do this out formally, we'd want to, of course, test the conditions first, which are very similar. But let me just make a very important note here, that if you were to do this formally, in the conditions, you wouldn't have a pulled p, because once again, this is not a hypothesis test. You would use the individual p hats, just like you use the p hat in your conditions for just one proportion. Okay, so it would look something like this. You'd have to go through all of that. Okay. And so for our problem, right, if we take a look at those two proportions, and if we were to do the difference in the two proportions at the 95% level, Now, our hypothesis test, or the one that I just did with you, was one-sided, so we couldn't use this exactly in the setting of the hypothesis test, because we know that that can only be used if it's a not equal to test. But you'll notice that if you go to stat tests and you go to down to 2 prop z interval. So this right here, 2 prop z interval, it's B on mine. Okay, hit enter. Okay, you'll notice that the values from the 2 prop z test are already in there. We calculate that, right? Obviously, if it wasn't already in there, you could enter that in. We get the confidence interval of the difference in the 2 proportions. Now, if this were a two-sided test, okay, the difference of the 2 proportions that I have here between East and West Woburn is between 0.00175 and 0.04923. The really important thing here is what this interval does not contain, right? This interval does not contain 0. So 0 is not a plausible value, right? It would be very unlikely to occur within this confidence interval, right? Because I'm 95% confident that the true difference in the proportions is captured in this interval. This interval does not contain 0. And so this would not be good evidence that there is a difference, right? But the fact is that you would know going in that you would want to prove one higher than the other. Right? You know if something's going on in East Woburn, seems to be more birth defects than West Woburn. Okay, but confidence intervals are sometimes used as an approach depending on what you're going for. Okay, focus for this week, 2 proportion z test and 2 proportion z interval. So if you could take some time to do that first section before we meet this week in class, that would be great. So that would be just 10.1a. And I'll have a couple problems that I'll do during our Zoom session this week. Thanks a lot. Have a great day.